Hi everyone, my name is Milan Latinovic. I'm a software engineer and PhD student at Graz University of Technology in Austria. It is my pleasure to present you this paper, Automation and Artificial Intelligence in Software Engineering, Experiences, Challenges and Opportunities. It is already known that automation and artificial intelligence have a transformative influence on many sectors. Within the existing literature, we found different examples on how automation and artificial intelligence were applied to these sectors. So, for example, increased automation and deployment of data analytics and artificial intelligence has been coined Industry 4.0 or smart manufacturing. In medicine, the performance of machine learning computer-aided detection and automated diagnosis in radiology is comparable to that of an experienced radiologist. Finally, autoencoder neural networks can help financial auditors identify unusual journal entries in an audit context. So, from previous examples, we can clearly recognize that automation and artificial intelligence have a transformative influence on many sectors. We recognize software engineers as the actors who engineer this transformation. However, there is little knowledge on how automation and artificial intelligence impacts them, meaning software engineering practice. We approach this problem with two questions presented on this slide. First one, aiming to understand the current practice. So we are asking, what are approaches for automation and artificial intelligence enabled tools and practices adopted by interviewed software engineers? Second question is aiming to understand the attitudes, hopes and concerns of software engineers. In this case, we are asking, what are software engineers' outlook towards the future of automation and artificial intelligence enabled support for their work? In the early stage of our research, we were thinking about which approach to take. For finding answers to our questions, we decided to conduct a qualitative research based on semi-structured interviews. We wanted an opportunity to listen and take notes first and then discuss. We did this by means of screen share, typing quasi-verbatim notes and sharing them with our participants so that we can discuss, validate and agree on those. Our questions started from common questions to get to know our participants better. What is their job? What their company does? Then, we wanted to know more about their environment, also about which part of their work is actually automated. We were curious if they have automated something themselves. We also wanted to know who initiated automation in their company. Finally, at the end, we asked if and how is artificial intelligence fitting in their activities. Once we gathered data, next step was analysis. Here, we did inductive and reflexive thematic analysis. Inductive in this context means reading through notes and identifying a priori unknown patterns in the described experience of our interviewees. Reflexive means we were describing and summarizing the experiences of interviewees. We developed teams during the data analysis, and these teams, compared with literature overview, provided answers to our questions, but they also triggered additional discussion topics. Within this slide, you can see part of our paper representing interview participant profiles. We interviewed experienced software practitioners across front-end, back-end development, DevOps, research development and integration as well. Our main aim was diversity. This diversity was in gender and age, sector, industry domain, professional position and also technology stack of our participants. We recruited our participants through online LinkedIn network and also in person with corporate environments and conferences. Some participants recommended others for interview as well. One of the first things we recognized, even during interviews, was enthusiasm toward automation. Software practitioners have common activities they need to automate. For example, environment configuration. New developer needs to set up his working machine, his development machine. He could do this with nice automated script where he runs this script once and everything sets up automatically, or he can spend hours or days manually configuring and going through installation tutorials. Then there is a static code checking, meaning recognizing if the code syntax is good. Is there a dead code? Are there some obvious bugs, some bad coding practices, also known as a code smell? All of these things can be recognized manually by a developer, but also there is automation which can recognize this for developers. Then, when it comes to testing, running tests automatically when new code is sent to server is also something that was coming up very often in our interviews. What we picked up from all these things is that actually developers are using different tools and approaches to accomplish same automation goals. The second theme is what we defined as process bridging with micro-automations. Software development companies have different processes. Each process is a set of steps that initially have to be done manually. When developers have a large number of manual steps, mistakes can happen and some steps can be forgotten. Also, if steps are having between different environments and systems, this can be time-consuming. This is the reason why developers are writing micro-automations to make their work easier. In their nature, micro-automations are usually implemented in form of custom script, automated configurations, development helpers, testing optimizations, and so on. In the given example, developer wants to make backup on specific server, and as a result he needs backup hash. He triggers script on server which is automated backup procedures. This procedure is connected with team chat where backup hash is delivered. There are multiple benefits from this simple automation. First one, developer does not have to do backup manually. Secondly, hash is saved in team chat where everyone can see and use it. And finally, everyone is aware that backup activity is happening and that there is clear history of backup actions. One of our most interesting findings is that automation of software engineering is a bottom-up driven. Meaning our participants reported that top-level management was not the one who initiated automation. Also, automation is usually side effect or bonus activity, but rarely the goal itself. One of our candidates compared automation with defensive player in football, also meaning that everyone knows automation is important, but there is no immediate cash return out of it, which then makes it a lower priority than the actual activities which are providing immediate cash return. Most of our participants reported automation as quick solutions tailored to a specific context and need in their companies. Our participants also reported different effects of automation on their work efficiency. What we need to understand here is that automation is usually a black box for a person who uses it. Meaning automation does something for software developers, but they want to be informed about it. Still, not all automation tools are good at this. For example, we had reports of automated tools which were sending large numbers of notifications. This required software developers to constantly get distracted. They have to check or double check these notifications for some things that they already know or that they might not be interested in. Sometimes automation would send a lot of data which is not useful, or at least it's not structured in some useful way. Our biggest takeaway from this is that automation should communicate with software developers, but by providing good data with good context if needed and when needed. When it comes to artificial intelligence and impact on software engineering, results were unclear. Our interview participants have not reported artificial intelligence-enabled tools which are substantially changing their work. When we asked them how they feel about artificial intelligence as helping tool or as a teammate, responses were mixed. Most of them were enthusiastic about having artificial intelligence as a helping tool. However, they did not see artificial intelligence as an independent final decision maker. Let's make an example to make this a bit more clear. Having smart coding assistant which recognizes issues and offers solution and advice is one example of artificial intelligence helping tool, and this is something that our participants would like to have in their toolset, of course. Then again, artificial intelligence tool can also implement this same solution and deploy it directly to server without consulting developer. Well, this is something that our participants were not so enthusiastic about. Our research provided several interesting results. In the paper, we provided our interpretation of these results, also taking into consideration existing literature review. This resulted in different discussion topics. For example, how are bottom-up automation and micro-automation linked? Is it possible that bottom-up nature of automation leads to micro-automations? This would make sense because it's not likely that bottom-up perspective can result in scalable solution which is implemented across complete organization. It simply might not have complete perception, motivation, or required resources to do so. On the other hand, we ask ourselves what is causing automation to have this bottom-up nature. Is it because of nature of software engineering? Maybe because software engineers know how to automate, they simply do it, but only within the area of their work without scaling it. And finally, how to evaluate socio-technical effects of automation, how to calculate cost-benefit of automation. We find these very interesting discussions with both theoretical and practical implementations. Our interviewers were enthusiastic about AI-enhanced tools, but skeptical about AI being in a driver's seat and making decisions. In literature research, we recognize different AI-driven applications. For example, code error prediction, error localization to help developers write code, and assistance in effort estimation to help project managers define efforts based on different algorithms. We asked our participants what they think about these applications. Answers were different, but constant was enthusiasm towards AI-enhanced tools, but skepticism towards AI-driven tools. This is something that requires careful implementation. We must take into consideration that our participants were not AI experts. Still, maybe software engineers do not seriously engage in thinking how is their profession affected by artificial intelligence. On the other hand, maybe software engineering is moving towards skill diversity phase. This would divide software developers between users and architects. Users would do programming supported by AI, while architects would create AI-enhanced and AI-driven tools. These are all very interesting topics where additional research should be conducted. I hope that you enjoyed this brief presentation. Please find more details in the paper itself. If you have any questions or ideas, feel free to reach out via LinkedIn, or you have my personal website as well. You can contact me at my IEEE email address. Once again, thank you for your interest in this research and stay safe.